Alright, so this first video is going to be 1 through 7, and the first part of it is just graphing these quadratics and analyzing them for behavior. So the first thing I want to do is sketch the graph. Now, what I remember is that from vertex form, the vertex is at the horizontal shift and the vertical shift, and -4 on the inside, I remember, makes me go right 4, and the +1 on the outside makes me go up 1. So the first point is going to be at, the vertex is going to be at the point 4, +1. So make sure you note the scale. This is 4, that's 1. So there's my vertex. And then I don't know if you remember, but the quadratics have a pattern. It has to do with, squaring numbers. So if you go over 1, you go up 1. If you go over 2, you go up 4, because 2 squared is 4. And if you go over 3, you go up 9, right, from the vertex, unless there's a vertical stretch or compression, which there's not. So I go over 1, up 1, over 2, 1, 2, and go up 1, 2, 3, 4. And I'm not going to be able to see over 3, up 9, so that's as much as I can graph. And then there's symmetrical, so left 1, up 1, and left 2, up 4. Now the other option is you go to y equals and you type in the function x minus 4 quantity squared plus 1, and we just go to the table. Let me make sure my table is set. Okay, second table. And I can see that at 1 it's 10, which I can't see. At 2 it's 5, which is what we have. At 3 it's 2. At 4 it's 1. At 5 it's 2. And at 6 it's 5. Okay? So those are the points that I would graph anyway. Okay, so then I connect and draw my parabolic shape. So there's my parabola. And then I need to answer all these questions. So A, ask for domain and range. Now, domain is left and right, so when I think about how far left and how far right the function goes, I know that domain is -infinity to +infinity on the x, and if I look at this graph, it will extend all the way on both sides. So you can either write -infinity to +infinity, or you can write all real numbers. Okay? Now range is up and down, it's the y values. So if I think of it as y values going down to -infinity and up to +infinity, right? What I see is that it doesn't exist below 1 on the y-axis, right? So I know that my range is starting at 1, which we actually reached because we have that point there, so I'll put a bracket, and then up to infinity. Okay? Part B asks for increasing and decreasing. So B, increasing and decreasing. So increasing and decreasing is always going to be intervals of x and only parentheses, not brackets. Okay, so parentheses, not brackets, and only x's. So on the x-axis, I see that at 4, I stop decreasing and start increasing, right? So I would say I am decreasing from -infinity to 4. And then I am increasing from 4 to infinity. And there we go. The next part asks for the x and y intercepts, C. So the x-intercept is where we cross the x-axis, and it never does, so none. And, y-intercept is where we cross the y-axis. Now, the y-axis, I don't actually see it, but I can do one of two things. I can either look at the table and go, okay, I know that's when x equals 0, and I see that that's 17, so 0, 17. Or I can just think about the function and plug in 0 in there. So I've got 0 minus 4 squared plus 1 equals y. 0 minus 4 is -4, but -4 squared is +16. So I've got, I'm thinking 17. 16 plus 1, and that is 17. Okay? So when x equals 0, y equals 17. But it would be just as easy to go ahead and go to the table. All right, D. D asks for the extrema. Now the extrema are the extreme values, and as far as maxes and mins, I don't have a max because it just keeps on going up forever and ever, but I do have a minimum, and it's at the vertex. So this is a min at the point 4, 1. And then in behavior. So in behavior has to do with what your behavior is at the ends of the function. So as you go to the left, where's the function going? And as you go to the right, where's the function going? So I know that as x goes to negative infinity, so we're on the x-axis, right, going to negative infinity, the function is going up to positive infinity. And as x goes to positive infinity, the function is also going up to positive infinity. And there we go. All right, number 2. Very similar, but this has a negative 2 in the front. So let's talk about what that does. I am still going to go left and right, so, or not left and right, left and up. The minus 4 makes me go left 4, and the plus 4 makes me go up 4, so that is my vertex, no matter what the stretch or compression is, so left 4, up 4. So there's my starting point. But having a negative 2 in the front, a negative 2, well, a negative flips it over, so instead of the parabola going up, it will now open down, right? And then a 2 does this, so I'm basically going to start and I'm going to go like, okay. So normally I would go over 1 and up 1. I'm going to go over 1 and down 1 because of the negative, but I'm going to multiply that by a 2. So I know I'm going to go over 1 and down 2. Normally I go over 2 and down 4, but I'm going to multiply that by 2, and I know I go down 8 now. So over 2, 1, 2, and go down 8, so that puts me at negative 4. Symmetrical, and it will be stretched out, right? So normally it's over 1 up 1, over 2 up 4, because you're squaring 1 squared and then 2 squared, right? But I'm going down because of the negative, and then I multiply it by 2 because I'm stretching it by a factor of 2. But again, I can check it. So negative 2, plus 4, and then plus 4. So I go to, well, I could just graph it real quick so you could see. And it should look like that, and then I go to the table. And I see that at negative 2, we're at negative 4. At negative 3, we're at positive 2, and at negative 4, we're at positive 4, and then we go backwards and go back, do that. Okay? So there's my graph. Okay. Domain and range. So a domain and range. So domain is left and right, and this function goes all the way left and all the way to the right. So on the x-axis we've got negative infinity and positive infinity, and it goes both ways. So that is all real numbers or negative infinity to positive infinity. I'm going to partition this off. Okay, on range is up and down, so I've got positive infinity, I've got negative infinity, and I see that this is where I actually stop being defined, okay? So it looks like the highest we go is 4, so my range is negative infinity to positive 4. And remember, we always go low to high, not high to low. So the low number to the high number. Okay, part B. B asks, increasing and decreasing. So, whatever. Increasing and decreasing. So I notice that the vertex, I stop increasing and I start decreasing. So I am increasing on this interval and decreasing on that interval. So I'm increasing from negative infinity until negative 4, not the y value, don't say positive 4, it's until x equals negative 4. So I'm increasing from negative infinity to negative 4, and then I am decreasing from negative 4 until infinity. So we're talking about intervals of x. Okay, and I'm even going to say that in the direction on what interval of x is the function increasing or decreasing. Okay, C. I need the x-intercept and the y-intercept. The x-intercepts, I actually have 2. So the y-intercept, well, let's just go ahead and go with the x-intercept. I don't actually see what they are specifically, so I'm going to have to go to the graph. So I have my function graph, so I'm going to go second calculate, and I want to find this 0. It's when y equals 0. That's your x-intercept. So I'm going to find this one first. So I'm to the left of it right now, so I press enter, and then I go to the right of it, and I press enter, and then it finds where it crosses in between them. So one of my x-intercepts is negative 2.586, comma 0. And then the other one, second calculate 0. So I need to be to the left of this point right here, which means I need to be below it. So that's to the left of it. Press enter, and then I need to go to the right of it, which is above it. Press enter, and I get negative 5.414, comma 0. So those are my two x-intercepts. Now my y-intercept is where across the y-axis. So I can do that one of two ways. Again, I can just go to the table and look when x equals 0. I get negative 28. Or I can just plug in 0 into the original function. So if I plug in 0, I get negative 2 times 0 plus 4, quantity squared plus 4. 4 squared is 16, and 16 times a negative 2 is negative 32, plus 4 is a negative 28. Okay? C asks, D. D is the extrema, and we have a maximum or a max at the point negative 4, positive 4. And then last thing, E, end behavior. So as x approaches negative infinity, y approaches. As an x approaches positive infinity, y approaches. Okay? So basically this is just as you go left and as you go right. As you go left, it goes down, and as you go right, it goes down. So either way, they're both negative infinity because they're both going to negative infinity. Okay? And there's number 2. So number 3. Number 3 is not in vertex form, which means I have to type it in and plot points from there. So I'm going to go to y equals, clear it out, and type in negative x squared minus 7x minus 9. And then I'm going to go to my table. Okay, so what I would do is always look for, well, any points that you're going to be able to see, but also look for where it repeats itself. So I see that at negative 6, I'm at negative 3, which I can't see on the chart. So I'll just go negative 5, 1. So negative 5 is at positive 1. Negative 4 is at positive 3. Negative 3 is at positive 3. And negative 2 is at positive 1. And then negative 1 is at negative 3. So just to kind of get an idea, I'm going to go ahead and put dots down here so I can see where it's going. Okay, now before I actually plot this, find the max, or plot the parabola, I do need to find the max. So I can calculate, and I can tell it's a max because it's symmetrically going down. So maximum, and I'm going to go to the left of the max, and then go to the right of the max, and press enter, enter, and I get that the max is at, so I'm going to go ahead and do that, B, C, and D, and that we have a max at the point negative 3.5 basically, and 3.25. So negative 3.5 and 3.25. So here's 3.5, so 3.25 is like right there. Okay. So I know that I'm going to that point, and come back down and head towards that point. Okay. So there's my problem. A asks for domain and range. So I don't know if you've noticed this, but the domain in all of these has been all real numbers. And so it is again. We go left and we go right, all real numbers. So domain is one or the other. And then range is up and down. And I see that I go all the way down to negative infinity, but the highest I go is this y value right here. And that y value is 3.25. So my range is negative infinity up to 3.25. Alright, B asked for increasing and decreasing. So I know I am increasing until I reach negative 3.5. So from negative infinity until negative 3.5, I am increasing. Negative infinity to negative 3.5. And then after that, I am decreasing until positive infinity. So yes, we're going down to negative infinity, but I'm only talking to x values. So from negative 3.5 to infinity. Okay, C asks for x-intercepts and y-intercepts. So x-intercepts, I know I have 2, and then y-intercept. So y-intercept on these is actually really easy because it's in standard form, it's just negative 9. But if I'm unsure, because like when x is 0, that's 0, that's 0, it's just minus 9. But I can always go to the table and see that at 0, the y value is negative 9. So the y-intercept is negative 9. But the x-intercepts I'm going to have to find. So I can calculate 0. I go to the left, I go to the right, and then I press enter, and I get one of them is negative 5.303 if I round, and the other one, so I'm to the left of it, press enter, go to the right of it, press enter, and I get negative 1.697. Alright, so the last thing I need is the end behavior. So what I know is that as x goes to negative infinity and x goes to positive infinity, in both cases the function y is going to negative infinity. So they are both negative infinity. Alright, that's 1 through 3. Now let's go 4, 5, and 6, and 7. So these are graphing radicals, so the inverses of the quadratic. So one thing I know is the pattern on radicals is the exact opposite of the pattern on quadratics. So on a radical, instead of going over 1, up 1, and over 2, up 4, because you square it, we're going to go over 1, up 1, over 2, no, sorry, over 4, up 2. And the reason why I know is because we switch from over 1, up 1, over 2, up 4, right, because they're the inverses of each other. This 2 squared is 4, well, the square root of 4 is 2. So that's why we're switching, okay? And then I go over 9, up 3. And then I go over 16, up 4. So it's just the square roots of the numbers that we know. So I first need to find the vertex, and this makes me just shift to the right 4. So, and no up or down because there's no plus or minus on the outside. So my vertex is the point 4, 0. And then I'm just going to follow the pattern. Over 1, up 1. Over 4, 1, 2, 3, 4, up 2. And over 9, 9 from 4 is 13, and up 3, 1, 2, 3. Now the other option, obviously, is to go to y equals, and type it in. X minus 4, and go to my table. And it doesn't exist until we get to positive 4. At 5 it's 1. At 8 it's 2. And at 13 we're at 3. Okay? So I just connect, and the only other thing I need to do is find the domain and range. So domain is left and right, so I know that the farthest to the left it goes is 4. So we go 4 to infinity. And range is low to high. So the lowest it goes is 0 on the y-axis, and it goes up to infinity. So 0 to infinity. Okay. On the next graph, we don't have a left and right shift because there's not a plus or minus on the inside with the square root, but we do have a plus 2, so I'm going to shift up 2. Now normally, I go over 1, up 1, over 4, up 2, and over 9, up 3. But I have a vertical compression by a factor of 1/2, so I multiply the vertical heights by 1/2. So I only go up half of what I normally would. Normally I would go up 1, now I'm only going to go up 0.5. Normally I would go up 2, now I'm only going to go up 1. And normally I would go up 3, but now I'm only going to go up 1.5. So from this point I'm going to go over 1 and up a half. And this is just a half. So make sure you notice the scale. And then I would go over 4, 1, 2, 3, 4, and go up 1 instead of 2. And then I would go over 9 and go up 1.5. So 1.5, 1.5. And there we go. Okay, so then I need domain and range. So again, domain is left and right. So the farthest to the left I go is 0 on the x-axis, so 0 to infinity. And the range is low to high. So we've got negative infinity and positive infinity, but the lowest it goes is 2. So 2 to infinity. Now number 6, we've got a left 4 and an up 3. So I'm going to go left 4 and up 3. And then this negative means that instead of going to the right and up, we're going to go to the right and down. So 1, 1, 4, 2, 9, 3. And then the 2 is a vertical stretch by 2, so I'm going to multiply by 2. Okay, so I know I'm going to go over 1 and down 2 instead of over 1 and down 1. Over 4 and down 4. So 1, 2, 3, 4, and down 4. And then over 9 and down 6. So 9 from negative 4 is 5. And then down 1, 2. Did I go down 4? I did not go down 4. I don't know what I was thinking. 1, 2, 3, 4. Okay. And then over 9. And then down 6. So that's 4, 5, 6. Okay. All right. So remember, if I need to, if I'm unsure about it, negative 2 times the square root of x plus 4. And then plus 3. So I go to my table, and I see that negative 5 does not exist, and negative 4 is the first point, and that's at positive 3, and then positive 1, and then at 0 I'm at negative 1, and then at 5 I'm at negative 3. Okay? And then domain and range. So domain is left to right. The farthest to the left I go is negative 4. So we're talking negative 4 to infinity. And then range is up and down. So this is a little bit different because the lowest I go is negative infinity. The highest I go is actually just 3. So negative infinity up to 3. Alright, and the last thing I need to do is write a function with those transformations. So I know I'm going to have a square root and x and whatever it says. So up 5 means plus 5 on the outside. Right 3 means minus 3 on the inside. So outside is exactly what it looks like, and then inside is the exact opposite. And then vertical compression by a factor of 1/2 just means multiply by 1/2 on the front. And there is 1 through 7.